Yellow. So welcome to part 4 of my series, and this is going to be short because I myself have not actually done much except playing around, and I think what I've discovered is pretty fun, not only for people who are interested in the AI aspect. I think it's pretty interesting if you're into Gran Turismo and want to just mess around. So without further delay, let's get into it. So let me show you what we got going. Yeah, let's remove this presentation, get Redux loaded, and check this out. So looks like we got almost what we wanted, right? Pretty clean. We clearly have every single line. We got the lines that are here, this track limit, we got this upper track limit. So I don't know if you guys can notice, this is the high speed ring, we're off track at the moment. So yeah, we still have the lines that would have been the shadows. But yeah, other than those, we still got a very clear line of the track limit. So if you remember, corner 1, we got the shadows coming up on the right banking. But look at that, we still got this clean edge, which is the track limit, almost. And we got a clean line here. So how did I do it? That's what I'm going to cover in this video. So if you guys remember where I got to last time, we had us trying the different methods of doing edge detection using OpenCV. So actually I've played with some different methods, and let's fire up Redux. And because I'm getting lazy, let's say we're here. And oh, you're not seeing that, so we're here. This is my code. So it's based on last week's, last video. It wasn't even last week. And yeah, remember, so playing around, I tried different settings, and I think possibly we can get it to work. But there's a lot, still way too much on the screen. So this is, I think, close to doable, but look at that. Here we cannot see the track edge. So let me remember, what did I do in this sheet? I think I tried different methods. Oh no, and this is literally what we tried last week, isn't it? So what was this one? Yeah. So we couldn't get a clear edge, and I kind of gave up. I did what most people do, go onto the internet, because my hypothesis is, as difficult this problem is, it still should be easier than a real world scenario. I don't know, this is my assumption, because we got simpler graphics and we got cleaner streets, right? A real street might have trash on the curb and stains, and the road is chipped and so on. Whereas here we don't have any of that. So my assumption is gonna be easy. It's rewind, gonna be doable. So I found a bunch of videos which I haven't watched into and studied in too much detail, but there definitely are more edge detection methods, and I think this video by Chan He-Jian seems pretty promising, because he's using OpenCV. I think he's using OpenCV. It says curved lane detection. He's detecting curved lanes on real footage. So I don't know, should be doable, right? Maybe the fact that in a video game like the PlayStation 1's Gran Turismo, we don't have perfect curves. Maybe, I don't know, that makes it worse. We'll see. So definitely I want to study this. Came across this video. What did this person do? Let's remove his sound. We got some ads, so we can't play that. Here's another one. Detecting lanes. So actually it's fudging the edge or glitching, but it again looks pretty good. Now, of course, the one thing I observe is all of these motions are relatively slow. So I don't know if this is running on pre-recorded footage. There's another interesting one. So mute that. Again, using color transforms, and I don't know what actually are these lines. Shape transform, but whatever it is anyway, it's another seemingly successful here. And in fact, I think this is from the same guy. No, it's Dr. Tangerine. So, oh no, this was Sheng Shu. So yeah, definitely going to study all of those videos one day. Yeah, but in the meantime, what have I been playing with? So, two things. I wanted to remove the heads-up display from Gran Turismo. And spoiler alert, I've managed to do that. So if I show this again, we go into race mode. We're in the race mode, right? I'm gonna turn this off. Boom, no heads up. Click it again, there it is. So I think this is already one step in the direction we want to take, right? Because now I can definitely simplify the display, and hopefully this will make life easier for processing. You know, I won't even have to deal with the noise around. How did I do this? This is what I want to share with people. So Gran Turismo 2, there's a patched hack made by Silent, which removes the heads-up display. I actually got in touch with him and asked him, hey, is there a memory address you modified? It turns out there wasn't. That's not how he did it. He actually deassembled the game and found the jump instruction or whatever, wherever the routine for drawing the heads up is about to start, and he no-opt that process. Yeah, and my assumption was there's going to be a flag that turns on and off the heads-up display, and considering how every other variable like steering angle, so hold on if I show you what I mean. So if I come out to this camera view, so check this out. If I rotate the steering, you see the steering rotate. And I observe that this happens in any mode, in replay and time trial, so the memory addresses persist. And so, if you guys know, when you go into replay mode in Gran Turismo 1, you have this cinematic view without heads up, cinematic view with heads up, and first person with heads up. So I assume there's a flag. Silent told me he's not aware of one. I asked around in the PSX development scene, and someone found it himself for a version of the game that I don't own. And it turns out that memory address he found didn't work. So this is what I did. Let me show you how I found it on this game. So Redux has the memory observer. And yeah, we just assumed, rather I knew, but you know, it was going to be one or the other, is that, sorry, we want to go to the replay, so I have to do some running. Sorry about that. And let's see. So we'll let that run. It doesn't actually matter if we're playing or not. And so let's go to replay. So replay. So my assumption is heads up on is the default. So I'm looking for a flag that is 0. And then I'm assuming when heads up is off, we're looking for a flag that is 1, as in true. And that actually finished too quick, so we're going to do replay. And then we do the next scan. And it's showing us all the variables that were a 0 or 1. So we put the heads up on again, and let's look for 0. And let's look for, okay, so try again, look for 1, sorry, look for 1, do next scan, and then look for 0, next scan, and look, now, you see, heads up off, and this first address is 1, heads up on, and this first value is 0, and that's the address which probably turns up the heads up display. So I say probably, actually I know. And yeah, so I think I mentioned this. Redux has a Lua engine, so I've been playing with this Lua script. Ignore the stuff at the bottom. So here it is. There's a checkbox for 6358. So it's to that memory address, the same memory address we just found in Redux to be responsible for it. And in fact, if I tick this on and off, you can see that the current value changes. Yeah, and I actually had a look. So this is the copy of the PAL region I have, the NTSC America region I have, and the NTSC Japan region I have. And those are the three flags. As it turns out, these flags mess the loading of the game in the other regions, so that's something I want to deal with. And by the way, this is also how I found, well, it's kind of how I found some of the other variables like speed, vehicle speed. Ironically, gear is a variable I spotted visually with my eyes, so most of these variables are all in similar region of memory, so it's probably some form of struct or object class. Well, actually, not classic definition of an object class because probably written in C. Yeah, and actually found other stuff which I haven't yet done. So again, cool feature of Redux, if we type the lap time, for example, the best 680, we'll find that in memory. And if we see the memory editor, try again, replay, there we go. And there you go, 007680. So that's the memory address with the timing. Also, this is the same way I also found the variable memory position for the car position in the race. So check this out. This is showing 6. I move this. It's saying we're first even though we're at the back. Now, I'm holding the mouse on because this is not persistent. Every loop, the game is going to calculate what position we're in and override that memory address. Whereas the tick box is coded to set that bit as we want to every loop. So probably need to do something similar if I want these values to permanently overrule. Incidentally, let's check, does this turn on the brake lights? No, it doesn't. In this mode, we might just be breaking the game. Anyway, so some stuff that I have figured out or I mentioned is the different regions of the game and how these memory addresses are different for different regions. So in fact, all of yeah, so this is miscellaneous, or let's say other region stuff. And actually this is all for the version of the game. So what I want to do is make this menu only appear if that's the version of the game we have. So this is what I'm going to do. So Nick has helped me to check region detection started or PTY region. So it's a get current ISO reader, and if it's confirmed that it's opened those versions of the game, it will respond false to failed. Or no, wait that. So if it opened the game, yeah, false will be failed will be false, and therefore the not of the false is true, and therefore we know we have the PAL. So let's think, how do I want to do this? So I want to do this like this. We start off with game, let's say, assuming that we don't have any version of the game, because that's how we roll. And let's put this at the beginning. And then that will be set to true or false. And let's print. Let's keep the print. It would be nice if I have a quick way. I think I'll revisit this code. I'll make it that we count. Yeah, we'll count. So for example, or numerate, like PAL is 0, US is 1, Japan is 3. Or in fact, we probably do none is 0, PAL is 1, US is 2, Japan is 3. and that way I can then index a list to say no version detected, PAL version detected. But anyway, so now what we want to do, what we need to do, if that's PAL, then yeah, indent all of this, and else if has US, then yeah. Oh, turns out and else if has, yeah. Here we go, and I think we have to end that. Let's see. So, and unfortunately, this is not actually the Lua file I have loaded. So hold on. Give me a second, guys. Need to make sure I open the right Lua file or copy and paste this. So this is the Lua file that I have saved. I think it's the Lua file I have saved in Explorer. Yeah, it's Lua file I've saved in my GitHub. It's actually not the Lua file that I'm currently loading into Redux. So bear with me a sec. There we go. So paste all over that. Boom, done. So let's see if that works. So let's reload the game. Now the emulator. Let's open the ISO. And let's load file gt.lua. That's what the file name is called, and execute. Okay, we got an issue. So attempted to call a nil string 1. So where's that? Open recent. What did we just open? Okay. This is what happens when you get used to life in Python. Still got an issue. String 1 attempt to call a nil value. Why? So let's see, it's loading that. I don't know, let's just see what happens. If we comment out all of that, and yeah, that's the right version. Okay, attempt to call a nil. Okay, I'm not sure where this error is being caused, so let's see what does the wise internet tell us. Lua. Okay, so it says this happens when we try to call a function that doesn't exist yet. I rather think we have some issue with some indent. Because look, here we got the. You know what? I'm gonna uncomment that because to me it makes sense that we need to define them first. And do we still have the issue? Okay, so we still have the issue. What's the error? expected symbol. Oh yeah, you see, man, I'm so into Python mixing up. That's it. I think that was the only issue. Let's run this again. Good. So GT hacking is loaded and it's blank. Perfect. Then we're going to start emulation, and it's detected that we have the PAL version. And yeah, it's, and it works. And we have, it's not running the code related to the non-PAL version. Excellent. And you see everything works. We can change the gear ratios or the gears, and it's cool. Gear 0 is reverse. We can make the rev counter go up, and that's pretty weird, right? There definitely is some link to the physics of the game, because we're fully stationary. If I'm going to switch on my controller, fully stationary, and as soon as we make this RPM go, it actually tries to move the car, right? So something going on there. And it clearly has some code that once we hit the rev limit or some extreme value, boom, boom, it starts to jump up in gears. So pretty cool. So the next, so that's let's see, that's pom pom memory manipulation, right? So we removed the HUD. Let's take some, I don't know, screenshot related to this. For example, this is some stuff we did, and we can create, no, we can create a HUD-less view and a HUD view. And of course, I want to get all the other variables and stuff. So I think we're going to need lap time. I'm not sure yet. I just think probably somehow we need to use lap time and positioning to make the reward system for the AI. I think that is, if it races against other opponents, it must be rewarded or penalized for being behind or ahead. And lap time to incentivize it going faster. And of course, we have to be careful, because I suppose an intelligent agent in a race would not keep pushing forever, sacrificing the chances of winning by overdoing it. You know, you hear about it all the time in F1. He didn't need to push, he overpushed, he threw a race, blah, blah, blah. So next, texture manipulation. So Lua is pretty cool. Redux is pretty cool. It also has HTTP server. And if we go to the VRAM, so VRAM viewer, so this is the memory, what's loaded in the video memory of the PlayStation. So we got the two screen representations, which are the display buffers for the dual display buffer. And on the right, every texture, sprite, whatever you want to call it, that needs to be loaded in the game. Some of the images that we are seeing are from prior renderings. Like here you can see this is the arcade mode selection screen. It's actually not being used at the moment. It's residual memory artifacts. And down here, these sort of things are the the palettes to color up the textures, and that's why the textures are in funky colors at the moment. So I think these would be, yeah, so for example, if we put them 24, you can see, yeah, so not all of the textures are the same, using the same number of bits, but they're all using some palette somewhere, also known as CLUTs, C-L-U-T, color lookup tables. So here's what I had in mind. I want to solve, if I cannot solve by tuning my edge detection, the next idea I have was to try to tweak the textures, alter the textures of the track to make objects more easily identifiable. So I haven't experimented in detail of that, but thanks to Spicy JPEG, who helped make some simplified code. So, I mean, fundamentally it's simple. It's more that I didn't have enough time to look into it. So what we're doing is, what he did for us with some modifications, we're loading an image using Pillow. We're checking that it's an image with a palette and not an actual RGB or BGR or whatever value on the per pixel. And then what Spicy JPEG has done is written code to put the palette into a NumPy array and put the image with index values to that palette in another NumPy array. And then it uses an HTTP post to the Redux server to submit to overwrite that position in memory. And what I have done is prepare, let's see, this is texture 1. So whatever, I have this red, it doesn't matter that it's red, but a red box of some even by even dimension. I'm actually resizing it to 256 by 256. And because everything is half width in the VRAM, I am copying and pasting these images at pixel position 640 and at height 0 and at height 256. And you'll see this. This is really cool. So you can see the in-game screen right at the moment. And what we'll do is we'll run this code. It will open to the Redux HTTP server and submit these images. Check this out. And we'll see two things. We'll see the VRAM change. So check this out. We'll hopefully. To be honest, this is not the coolest. Hold on. So I'll make this false because I was experimenting as trying to blank out the whole of VRAM, and yeah, if we blank out everything, it's gonna be pretty dull. So I'm gonna reload the original game. Stop that. Okay, reload, sorry, the original state. Run this again. Check this out. We're gonna see the memory here be blanked out, and as we do that, we're gonna lose textures that are in the game, and conveniently they're more or less colored as to some color related because I'm not overriding the palettes. So every palette to every texture is still there. It's just that the texture is indexing probably only one color, and I haven't overridden the texture space related to the cars. So here we have the front side views of the cars, and here are some others. The gauges are here. Let's see, is it in 8-bit? Or yeah, it must be 8-bit, I guess. Maybe even 4 bits. There we go. So here's the fuel and boost gauge. Let's see, there's probably some wheels. Yeah, so most of the details for the car are still there. It's just every track related texture is gone, and now we have a very simple display. And to be honest, I think it's pretty fun to play it this way too. So yeah, let's take a screenshot of that to have evidence or record of what we did. So in fact, it's hard to notice that we have half the memory at the moment. So that is modded, and let's load. And that is unmodded. And I think that way you can clearly see what I have hacked off. A bit of OCD, though some may argue not OCD enough. So pretty cool, huh? Yeah, so definitely, I think if So I definitely want to stick as much as possible to the original rendering. That gives me the best possibility of implementing this project on real hardware. But if not, I think I will compromise to using this graphics hex. I obviously need to tweak it. So for example, it would be convenient to pick a color index that reduces the contrast of the floor. Of course, on the other hand, maybe, I don't know, keeping these contrasts can help give the vanishing point or perspective of the track. But I don't know if it's going to be important. But yeah, unlocking more doors or establishing more tools, and these tools can go in my chest of tools to tackle the bigger program. So yeah, I said it's going to be short video, still turned out to be 30 minutes long. Sorry everyone. If you are still watching my videos, or want to watch these videos, please press like, leave comments, subscribe, and all that YouTubey stuff. Thank you very much, guys. Bye bye.